This is Kuta's Simplifying Rational Exponents, number 17 through 22. So number 17, here we have m times m to the negative 2 times n to the 5/3, all squared. Okay, so when we do this, we can distribute the squared, but first, let's simplify what's inside of here. Well, we can combine these two m's, right? Because this one has an invisible 1 power. So this is m1 plus negative 2 and 5/3 squared, right? M, now 1 plus negative 2 means m to the power of negative 1, and still is the power of 5/3 squared. And now let's distribute the 2. So we get m, well, what's 2 times negative 1 is negative 2, and 5/3 times 2 is 10/3. Okay, because remember 2 is over 1. And the only thing we want to do is we only want positive exponents. So to make this positive, we need to put it in the denominator. So it's n to the 10 over 3 over m to the positive 2. Okay? And this is number 17. Let's go on to number 18. Here we have a to the negative 1, b to something, a to something, b to something squared. So again, let's simplify what's inside the parentheses first. So let's combine the a terms. We have negative 1 plus negative 4 over 3. And the b terms times b to the 1/3 plus 2. And don't forget that we have this all squared. Okay, so negative 1 plus negative 4 over 3. Let's do this work over here. Remember, what's the common denominator? Well, this is over 1. So if we multiply it by 3 over 3, we're going to get the common denominator of 3. So it's negative 3 over 3 plus negative 4 over 3. Now we can just add the numerators, and we get negative 7 over 3. So this is a to the negative 7 over 3 power times b. So we did that. Now let's also add 1/3 and 2. Remember, this is over 1. So if we multiply by 3 over 3, we get 1/3 plus 6 over 3. That's 7 over 3. Okay? So this is b to the power of 7 over 3 because we added these over here. And we still are going to square this. So now we can distribute the 2, and we get a to the negative 7 over 3 times 2. Remember, it's over 1. So this is negative 7 times 2 is 14 over 3. And b to the power of 7 times 2 is 14 over 3. Okay? So also we need to make sure is we don't have any negative exponents. And so we're going to move this negative 1 into the denominator. We get 14 over 3, b to the power of 14 over 3 over a. Now it's going to be positive 14 over 3. And the directions say no fractional exponents in the denominator. So I'm okay with this answer, right? But if we want to continue on, we want to get this fraction, 14 over 3. We want to make it a whole number, oops, not plus, equal to a whole number plus a fraction, or actually a whole number plus a negative fraction, or minus a fraction. Okay, so this 3 goes into 14, 3, 6, 9, 12. So 12 over 3 is an even whole number plus 2 over 3, right? That's the same as 4 plus 2 over 3. Or we could say, right, these are all equal. Or if I increase this and made it 15 over 3, right, that would be a 5. But then I need to subtract 1 over 3 to get 14. So this is going to be minus 1 over 3. Okay, so then I could say this is b to the 14 over 3 over a. Now instead of 14 over 3, I'm going to write it in terms of a whole number minus a fraction. 5 minus 1 over 3. Okay, and we're able to separate. Let me write that a little neater. Whoa. It's not writing. 14 over 3 over a to the fifth, right? Because this is the same thing as b to the 14 over 3 over a. Let me make this a bubble over here, to the 5 plus negative 1/3. So I can separate this to be a to the negative 1/3 times 5 to the, times a to the 5, right? Because if you combine these, it's going to be equivalent to that, which is equivalent to that, okay? And here I can move this into the numerator, so I get b to the 14 over 3. I move this up, I get a to the 1 over 3, positive 1 over 3, and a to the 5 in the denominator. So this is what the instructions ask you to do. They ask you to look at having no fractions in the denominator's exponents, but I'm okay with that. But if you want to continue on, this will be acceptable as well as this. Okay, let's move on to the next problem, number 19. This one we have x to a power, y to a power, y, well, we know this without a power is 1, x to a power, all raised to the power of 4. So let's simplify what's inside the parentheses first, okay? So what I'm going to do is bring everything up into the numerator. So I have x to the power of half, y to the negative 2. To bring y here up, I'm going to make that a negative 1 power, right, to the reciprocal. To bring this up, I'm going to make this taking the reciprocal, so now we're going to flip and make this positive 7 over 4, okay? And remember, it's all to the 4th power. So now let's combine some of these. So x, here we have two x's, so it's to the power of 1/2 plus 7 over 4 times y to the power of negative 2 plus negative 1, right? And this is all to the power of 4 still. So let's add 1/2 plus 7 over 4. Okay, to get a common denominator, I'm going to multiply by 2 over 2, so that's 2 over 4 plus 7 over 4, right? 7 plus 2 is 9 over 4. So this is, here's a bubble right here. Okay, so that's equal to x to the power of 9 over 4, because we just added that, times y. So let's find out what's negative 2 plus negative 1 is negative 3, okay? Now we can distribute this 4. 9 over 4 times 4 over 1. Well, 9 over 4 times 4 over 1, we can go ahead and say 9 times 4 is 36, and 4 times 1 is 4. Or we can see that we can cancel the 4 and the 4 right here, and we're going to get 9. Well, 36 divided by 4 is 9. So either way, it's going to be x to the power of 9, right? And then y, well, what's negative 3 times 4? It's negative 12. Right, and then we do not want negative exponents, so we make this into the denominator by making this a positive 12. All right, so now let's move on to number 20. Number 20 is, okay, something to this power and something else to this power. So now we don't want to simplify what's in the parentheses because we can't, right? This is already simplified, so we can distribute this, and we could distribute this, right? This only goes into what's in the parentheses, so it doesn't go into the denominator. So 3 times 3/2, so 3 over 1, that's going to be 9 over 2, right? Y squared, so it's going to be over 1. 3 times 2 is 6 divided by 2. 6 divided by 2 is 3. So it's y 3. You could also see that 2 over 1 times 3 over 2. These cancel and get 3 over 1, which is 3. Okay, here's a bubble work. Okay, over, now x to the negative 1. Now if we raise this to the power of 1/4, negative 1 times 1/4 is going to be x to the negative 1/4, right? And y to the power of negative 2 over 3 times 1 over 4. So that's going to be negative 2 over 3 times 4 is 12, right? Just multiplying the numerator and the denominator. Okay, so now I'm going to bring these up. So I have x to the 9 over 2, y cubed. And let's bring this up by making that a positive 1/4 power. and bring this up by making that a positive 2 over 12. Well, instead of 2 over 12, let's simplify this. This is the same thing as 1 over 6, right? So let's make this a positive 1 over 6. All right. Now we can go ahead and combine some of these. So we get these two x's. We add the exponents because they have the same base. So it's 9 over 2 plus 1 over 4 times y, 3 plus 1 over 6. So let's add these. 9 over 2 plus 1 over 4. So if we multiply this by 2 over 2, we're going to get common denominator 4. So 9 times 2 is 18 over 4 plus 1 over 4 is 19 over 4, right? This is a bubble work. So that's equal to x to the power of 19 over 4 times y, right? And then let's add 3 plus 1 over 6. So this is over 1. So to get the common denominator, let's multiply by 6 over 6. 6 times 3 is 18 over 6 plus 1 over 6. That's 19 over 6. Okay, let's bubble this because we just used it to do some work. So this is to the power of 19 over 6. Alright, let me make that a little more neater. Alright, so this is number 20. Let's go on to number 21. 21. Here we have these terms to this power and these terms to no power. So let's distribute the power in the numerators. So we get x to the negative 1/2 times negative 5/4. So negative times negative makes it positive. 1 times 5 is 5. 2 times 4 is 8. Times y. This is a positive, this is a negative. So, and remember, this is over 1. So this is negative 10. 2 times negative 5 is negative 10 over 4. Over x squared y to the 1/2. Okay. I can simplify 10 over 4. They can both be divided by 2. So this is negative 5 over 2. Alright. So now let's bring these from the denominator up. So that's x to the 5/8, y to the negative 5 over 2, times, now bringing this up, it becomes x to the negative 2 and y to the negative 1/2. Okay? So now we're going to just add these exponents. So it's 5/8 plus negative 2. And y, we want to add these exponents, negative 5 over 2 plus negative 1/2. Okay? So 5 over 8 plus negative 2. Well, I know that's over 1, so let's add these. The common denominator is 8. So we get 5 plus 8 times 2 is 16 over 8. So that's equal to negative 11 over 8. Okay? So let's go ahead and say we just added 5/8 and negative 2, so that's x to the power of negative 11 over 8. And then y to the power of negative 5 over 2 plus negative 1 over 2. Well, they have the common denominator, so that's just negative 6 over 2, and that can be simplified as negative 3. Okay? So now what we want to remember to do is we don't want any negative exponents. So let's put these both in the denominator and make them positive exponents, right? And we don't want fractional exponents in the denominator. Well, I'm okay with this. If you're okay with this, you can move on to the next one. But how do we get this to be a whole number in the denominator and a fraction in the numerator? Well, remember 11 over 8. That's equal to 8 over 8 plus 3 over 8, right? That's same as 1 plus 3 over 8. Well, can we increase that by 1? So let's make that equal to 2 plus something. Well, then we'd have to make this 16 over 8. And we'd have to subtract. To get to 11, we would have to subtract 5, right? And so that's equal to 2 minus 5 over 8. Okay, so then I could change this exponent to be x to the power of 2 plus negative 5/8 y cubed. And that's the same thing as 1 over x to the power of 2 times x to the power of negative 5/8 times y cubed. And that's the same thing as moving this one into the numerator as positive 5/8 power x squared y cubed. Okay? So this is if you want to follow the instructions completely. Again, I'm okay with this one or this one. All right, let's do number 22. This is the last one. So here, again, let's work with the numerator and denominator. So the numerator, well, let's go ahead and distribute the 1/4 power. So x negative 1/2 times 1/4. Well, the numerators you multiply across, so it's negative 1 over 8 times y. Well, 4 is over 1. 4 over 4, well, that's just 1. So I don't need to even write it. I could write it, but I don't need to. Same thing. And then we have it over x to the 2/3, y to the 3/2. Well, let me put these next to each other, the common term. So x to the 2/3, x to the negative 3/2, y to the 3/2, y to the 1/2. Okay? Because multiplication, it doesn't matter the order. And then let's go ahead and let's move everything up. So that's going to be x to the negative 1/8. And then if I move this up, it's going to be x to the negative 2/3. This up is going to be x to the positive 3/2. Then I have y here times y. If I move it up, it's negative 3/2. And y here, it's going to be negative 1/2. Okay? So that means we just have x, the common base, and we can add all those exponents. And we have y as the common base, and remember there's an invisible 1 here, so we add those exponents. Okay? So let's do the math over here. Negative 1/8 plus negative 2/3 plus 3/2. So what's the common denominator? Well, what you could do is just multiply each one by the other two. So that's going to give me a common denominator with this one, 3 over 3. And just for kicks, let's make it times 2 over 2. Because this will always work, right? So this one, again, I want to multiply it by the other two. So that's 8 over 8 and 2 over 2. And this one I want to multiply by 8 over 8 and 3 over 3. Okay? So that's equal to, what's 2 times 3 times negative 1 is negative 6. Okay, 2 times 3 is 6. 6 times 8 is 42, right? And again, we could even bring out our calculator. Actually, I totally need a calculator because 6 times 8 is 48, right? 6 times 6 is 36. 48 plus over 48. These are all going to be over 48 now because 2 times 8 times 3 is the same as 2 times 3 times 8, and so on. So negative 2 times 2 is negative 4. Negative 4 times 8 is 16, 32, negative 32. 8 times 3 is 24. 24 times 3, 24 times 3 is 12, 72. Okay? So now we just add these up. So 72 minus 32 is 40. 40 minus 6 is 34 over 48. Okay? We could divide the numerator by 2 and the denominator by 2. We get 17 over 24. Well, that was a lot of simplification just to get x to the power of 17 over 24. So we added those three. Oops, not right. So we added these three, and we get 17 over 24. Okay, so let me bubble that. And then we have y. So let's add 1 plus negative 3 halves plus negative 1 halves. Okay, so this is over 1. So if I just multiply this by 2 over 2, I'm going to get the common denominator. So that's 2 over 2 plus negative 3 over 2 plus negative 1 over 2. Right? Negative 3 plus that's negative 4 plus 2 is negative 2 over 2. That's equal to negative 1. All right. And then we just have to make sure we don't have any negative exponents. So let's put that in the denominator. We put it in the denominator. We don't need to write the 1 because it's implicit. Right? We could write it, but we don't need to. And we're done. All right. So this is the last problem in the Kuta simplifying rational exponents